So first of all, let's talk about F#. Well, the official description says that it's a functional first multi-paradigm programming language on .NET platform. And actually, it's a very precise description and unfortunately quite useless because people don't really get it. They basically go like functional first, what's that? And then multi-paradigm, yeah, okay, what language isn't? And when then they see the syntax of this language, they go like, oh, apparently it's Haskell on .NET, awesome. Well, no, it's not a Haskell at all. In fact, those are very different languages, so how different they are? Well, first of all, Haskell has a way more powerful and descriptive type system. And basically, for everything they have in category theory, there's something in Haskell, and it's probably even the other way around, and they actually update category theory in order to keep up with Haskell. But yeah, jokes aside, we don't have a lot of things in F#, like we don't have hierarchy types, we don't have type classes, we don't have generalized algebraic data types, and a lot of other stuff. And instead, we have a bunch of our own stuff, like object-oriented programming and C# interoperability and stuff like that. So when true functional believers discover those things, they go like, yeah, damn, that's not functional enough. I guess I gotta do everything myself. And yeah, they want to implement all those missing things, and they certainly don't like using this object-oriented programming here. And I can understand those feelings. I mean, what's wrong with modern OOP? Well, first of all, there is no solid theory behind it, unfortunately, so everything is based on someone else's experience, which means that everything is open to interpretation. So basically, you can take like 10 guys, lock them in a room, and ask them a simple question like, what is the right way to implement abstract factory? And that's it. They're done. They're never going to come to a conclusion. And if suddenly they do, well, you can ask them a second question, and yeah, there you go. Another big problem is mutability. And under these conditions, the state is a very hard thing to manage. So you can see this just by thinking how many problems can be solved by simply restarting your system. And the last problem is that usually languages in this modern OOP, they have a very weak and inexpressive type system, which basically means that you have to do a lot of things manually yourself, and this is like a boring stuff and tedious. So here's sort of a checklist. If you go fully functional, you have to emulate all those missing things, probably lenses. Some people even try to do dependent types, which is a crazy idea in F#. In order to achieve those things, they abuse aggressively SRTP. For those of you who don't know what it is, it's a statically resolved type parameters, but basically it's a hack from F# compiler in order to bypass certain limitations from .NET type system. And yeah, they definitely don't want to use any kind of OOP, and they go in denial with exceptions, interfaces, and mutability. Yeah, they fight like a younger man, but it's admirable but mistaken. Because F# isn't designed, unfortunately or fortunately, for those kind of things. So let's see the simple scenario. Let's say you have some kind of a document or a form, and you want a user to fill this out. But you want to have a good user experience, so you don't want to force your user to fill this out in one go. So what you do is you give him ability to save some progress in the middle. In Haskell, there is a very elegant and efficient way to do this. So basically, you define this one structure over here, and you put this mapping in there, and then you create two simple types, one with identity mapping and one with document, or with maybe mapping. So yeah, in one case, all the fields are required, which is exactly what you need when the document is finished. But up until that point, everything is optional. So this is a beautiful solution for this problem. But as I said, we don't have higher candidate types and data in F#. So here's what it looks like when someone tries to do this in similar fashion in F#. They define this purely generic type. Like you have 5 fields in there, so you have 5 generic type parameters. And then you defined 2 like implementations in here. One with all the options and one with plain types. And maybe it might even seem like a good idea because, well, you still have just one list of fields to keep updated. But there are certain disadvantages. Like first of all, now this type definition doesn't tell you anything because, well, it's purely generic. That's what you wanted. And another problem is that now nothing is forcing you to keep those types consistent. So you can mix options with other types, or you can just, I don't know, put integers or whatever in there. And from compiler point of view, it's a totally legit code. Like it's working. But from the human point of view, from the domain point of view, it doesn't make any sense at all. And yeah. If you don't think that this is a bad idea, just take a look at this one. This one is a little bigger. And let me remind you, this is all comes from an actual production project, unfortunately. Yeah. This is also, yeah, from production project. So over here you have like 70 generic type parameters. Good luck with that one. I mean, I used to work at this project, and I'm still not sure what exactly is happening in here. I have some idea, but yeah, anytime you try to modify a structure like this, you get a pure garbage of a compile errors. Nothing is helping you. Yeah, this is what it looks like when someone tries to merge 2 documents. Like this is supposed to be a simple thing to do, right? Well, I've spent a lot of time trying to figure out what exactly is happening in here. But what do I know? I'm not a true functional developer, for sure. So maybe if some of you will see this signature of this invoker in here, maybe you will know what's happening. So yeah, let me tell you, this isn't really helpful. And again, every time you try to update this kind of code, or you make some error, you're completely lost because nothing is helping you. You've lost the support of IDE, you've lost the support of a compiler to some degree. So this is a pretty bad idea. But that's not the only craziness that's happening. Over here is another kind of going fully functional. This is from another also production project. And basically, this is a simple sending of an HTTP request. And I thought that, like in 2020, this is supposed to be a very simple thing to do. But apparently not. So yeah, I mean, if you know your way around, you can certainly read this kind of stuff, but it takes me like 5 minutes, literal, to figure out what's happening. Well, I can do it like for 2 seconds if this was a decently written code. Yet another golden rule for some people is to avoid using exceptions at all costs. And I think I know where it comes from. Exceptions have a very unfortunate and notorious reputation in object-oriented programming because I think they have a very weak type system. So every time they want to represent something other than positive case scenario, well, exception is maybe the only comfortable way to do that. But when you build your logic upon exceptions, this code becomes very hard to control. Now you don't see your contract fully, and you have to go through all your implementation in order to really get the idea of what's happening. On the other hand, exceptions can really be useful when something unpredictable happens, something you didn't count on. And when that happens, you want to get as much details, as much information as possible about what exactly happened, why did it happen, and especially where in your code did it happen. But when people avoid using those exceptions, this is what they get. Basically, it falls up to their own shoulders to implement this sort of a stack trace. And of course, it's a garbage of a stack trace because there is no way that you manually update all the line numbers and stuff like that. And sometimes people just get sloppy and lazy and they just put an empty string in there. And yeah, good luck with figuring out. And oops, a little bit earlier. So another useful feature of exceptions is that they actually break your flow so that your error doesn't spread across your system. And you don't end up with corrupted data and even more problems than you had. So this has to be some kind of a balance in every way, because basically this is what actually F# is about. It's about combination of functional programming and OOP. So how do we find this kind of balance? I think the general rule has to be pretty simple. Like every decision you make is supposed to make your life easier, and otherwise it was a bad decision. So if you're going back to result and exceptions, for domain rules, for validation and authentication and authorization things, basically for the contract of your API, you definitely want to use a result, because this is something you want to express in the static way. But as soon as we deal with something unpredictable, probably some infrastructure errors, and basically whenever you need stack trace, yeah, guys, please just use exceptions and don't reinvent this kind of thing. And yeah, life will be easier. Another kind of a painful point can be type safety and pursuing this thing, make an invalid state unrepresentable, which definitely is a good idea in general. It's just, as usual, you have to be careful with it, because as everything else, it has certain advantages and disadvantages. Advantages that you get is, first of all, have more guarantees from a compiler. And this kind of guarantee comes for free, because compiler runs for free. You don't have to write additional tests. You don't have to maintain this code. You just write it once, and then it works. And this is kind of a good thing. Another advantage, if you make it right, is that types get more descriptive, and this can be like kind of a second documentation to your project, or maybe it's the only documentation that you get, unfortunately. But yeah, and at the end of the day, you can have fewer tests to write and fewer bugs to fix. But on the other hand, this is a tricky thing to make right. It's not that easy. And sometimes when you don't know where to stop, this is hard to comprehend. And of course, it's hard to instantiate this kind of type. And yeah, some things just can't be represented in static way, especially in a given type system. I mean, it can be just not descriptive enough. So the worst thing you can do is to go nuts with this kind of types and then don't get it right. You will get the worst out of both worlds, because on the one hand, your code gets extremely complicated and hard to manage, hard to read. And on the other hand, you're not getting any decent guarantees. You will still need to write a lot of tests for that. And yeah, or just hope for the best. So which brings us to the more general rule, like know your platform and accept it. And F# runs over a .NET platform, and you have to live with that. And .NET platform brings certain limitations, like metaprogramming is being done through reflection, and yes, reflection is a bit slow and it's totally unsafe, so you have to be careful. But at least on .NET reflection works, and it works fine. On the other hand, macros and type classes and whatever you try to implement yourself, this kind of thing usually doesn't work right. And it's also can be very slow, and yeah. So just deal with it, use reflection. Another thing is .NET itself uses exceptions underneath, a lot of them. So either way, you're gonna have to implement some kind of a global exception filter for that, even if you don't throw exceptions yourself. And of course, guys, you're better off using C# libraries, because it will save you time and money when it comes to making a production project, because there are a lot of things implemented already for you. So yeah, this is a very bad idea, trying to implement Haskell in a production project. You can certainly do this in your free time, in your pet project, or whatever, but in production you get paid for a different thing, and this means the conflict of interest. They're not gonna let you do your thing forever, which means neither of you end up happy. And another problem is you don't have tools for that, and yeah, you don't have time for that, and most likely you are not skilled enough as a language designer. Well, maybe you are, but probably not. I'm certainly not. And at this point, you might be thinking, then why the hell bother with using F#? Well, first of all, it has a very good balance, in my opinion, of F# and OOP. And you can say whatever you want, but sometimes OOP is just a better fitting tool for the job. And when you actually have an opportunity to comfortably combine those paradigms, this becomes a very powerful tool. And this C# interoperability in here means that you can actually add to the existing C# project, you can incrementally add your F# things. So this way, it's very easier for business to introduce a new technology. Besides that, we have very powerful IDEs. One of them is Rider, and another one is Microsoft Visual Studio. It also is available for Mac. And yeah, I mean, those are very decent IDEs. And yeah, you get a lot of libraries. You get .NET is a first-class citizen in all the cloud providers. And today, it's a very important thing to have, which means that you don't have to implement any kind of integration yourself. As soon as something gets released on Azure or AWS, there you go. You already have this support for .NET. And of course, we have a very big community, which means that you can, I don't know, easily find a developer. And since F# is a way more simple language than Haskell, the threshold is actually a lot lower. So introducing newcomers goes way easier, I think. And since we are talking about production projects, I think we have to remember this thing. Like for production project, I think for any of them, it's critical to have some kind of a database support, cloud integration and stuff like that. It's critical to have a decent developer community so that your whole business doesn't depend on one guy that knows this technology perfectly. And yeah, having a rich environment and decent tooling is also incredibly helpful. It might be not that big of an issue when you work alone for the project, but as soon as the team gets big enough, you're better off using some tooling for refactor and stuff like that. And yeah, as much as I hate to admit it, but any production project can live without these abstractions like hierarchical types without dependent types and even without functional programming. So yeah, we gotta remember that we're doing production development. Yeah, well, I believe that's it. So yeah, thank you. If you have any questions, feel free to ask. Yeah, here are some links. We have a wonderful site for anyone who wants to try Sharp. You don't have to have any kind of a background, just this site is beautiful. We have a wonderful, as usual, wonderful F# community in Telegram. So feel free to join, and if you want to take a look how a complete demo web API project looks like, you can follow this link. And yeah, that's it. So if you have any questions,